Hi, my name is Chad Clay, and today I'm going to be showing you how to do the AP Calc AB test from 2002, question number 1. So let's read it. Let f and g be functions given by f of x equal to e to the x and g of x equal to ln of x. And then question A is find the area of the region enclosed by the graph of f and g between x equals 1/2 and x equals 1. So first off, what's best to do, plug it into your graphing calculator so you can get a good visual of it. So e to the x, second ln of x, and let's take a look at the graph. So to find the area between the curves, you have to figure out which function is on top of the other. So as you can see by the graph, e to the x is above ln of x. So what you want to do to find the area between the curves is go get an integral and do e to the x minus ln of x, and then define your variable, set your bounds, plug in, and then you get your answer, 1.22299. So that's your answer for A. Now how would you write that on your answer sheet? What you want to do is write down your area is equal to the integral from 1/2 to 1 e to the x minus ln x dx. Very important to have the dx there, or else you won't get the points for the integral. Now for the answer, the College Board would either accept 1.223 or 1.222. It really doesn't matter, it's just how you prefer to round. And then units squared. So for a lot of the times, the College Board does not really care about writing units squared. But I like to do it just to remind myself that, hey, there might be units for other problems, So maybe another problem, it's like grams or something. So it's just to remember. So let's look at question B. Find the volume of the solid generated when the region enclosed by graphs of f and g between x equals 1/2, x equals 1 is revolved about the line y equals 4. So let's go back to our visualization technique. Let's go y equals, I'm going to plug in 4. And take a look at our graph here. So we're taking the area from our last problem and revolving it around y equals 4. So that means we're going to have an outer piece, or the outer edge, and then the inner edge. So our outer edge is going to be ln of x, because that's the farthest away from y equals 4. The distance from y equals 4 to ln of x is 4 minus ln of x. So that's going to be part of our integral. The smaller distance is going to be the 4 minus e to the x, and that's the distance of the inner part. So to find our integral, to use our integral to find our answer, here's how it would look. You want to multiply by pi, because it's a revolution, so you need to multiply by pi, that's the formula. You go integral, parentheses, 4 minus ln of x squared minus parentheses 4 minus e to the x squared parentheses, oh no, just kidding, not parentheses, comma x, comma 0.5, comma 1. And you're going to get 23.6095. So how would you write that? Again, let's take a look. So for question B, what you want to do is you have your volume is equal to pi, integral 1/1/2, bracket, parenthesis, 4 minus ln of x, close parenthesis, squared, minus 4 minus e to the x, parenthesis, squared, bracket, dx. Again, don't forget the dx, and I just put units cubed there to remind myself for the other problems, of course. Let's see, another issue. What you want to do is make sure that you have the bigger part minus the smaller part for your radiuses, or else you're gonna get a wrong answer, and you'll get the whole question wrong because you didn't get the integral and you didn't get the answer. Now let's take a look at letter C. C is let h be the function given by h of x is equal to f of x minus g of x. Find the absolute minimum value of f of x on the closed interval 1/2 between 1/2 and 1. Find the absolute maximum value of h of x on the closed interval 1/2 to 1. Show the analysis that leads to your answers. So let's take a look on how to do this. So h of x is equal to f of x minus g of x. Or h of x is equal to f of x minus g of x. So to find critical points, what you want to do is take the derivative of that. So you have h prime of x is going to be equal to f prime of x minus g prime of x. Forgot that one part. And then your next step is going to find your h prime of x and plug in for the function's derivatives. So it's going to be e to the x minus 1 over x, because the derivative of e to the x is e to the x, and the derivative of ln of x is ln of x. Then what you want to do is solve for x when the equation is equal to 0. And if you do that, you can use your solve function, a graphing calculator. So what you want to do is have e to the x minus 1 divided by x equal to 0. Define your variable, enter and solve. Give it a second. Okay, maybe a few seconds. But when you do that, you're going to end up getting 0.567143. And that's going to be one of your critical points. You also need to remember that your critical points are also going to be your bounds, because it's absolute. You're looking for the absolute maximum. So then what you do is you're going to plug in each one. And so when you plug in each one, you're going to h of 0.567143 is equal to 2.330. H of 0.5 is going to be equal to 2.3418. And then if you look up, you get h of 1 is going to be equal to 2.718. So your absolute min is going to be 2.330. Your absolute max is going to be 2.718. And those would be your answers. And it said how you needed analysis in the question to get the correct answer. And so I wouldn't really worry about that. As long as you have this part right here, that's good enough for your explanation. You don't need to write a sentence. Now, possible sources of error. What you want to do here is make sure all your calculator stuff is correct. Don't mess up on your parentheses. Make sure you're plugging in right values. On some calculators, you have to do the second and then the green triangle or green diamond thing. Make sure you're pressing the right one. You don't want to get the wrong one there. Make sure you have the correct order when you're plugging in for your revolution. And then make sure you're using the endpoints for your critical values. So, sources for more practice. If you have those AP review books, maybe like Princeton Review or Barron's, those are going to be excellent sources. You may even be able to find some problems online. I have a nice Princeton Review book that has plenty of practice. You could also Google on the internet and maybe find some questions from College Board. They might give you a few, because I know they do some practice for each AP test. But the problems from College Board are a little trivial. So I would maybe do those for, I don't know, if you're just trying to relearn it. But I would say if you want the real hard practices to get you fully prepared, Princeton Review is where it's at. That's my suggestion to you, and I hope you now understand how to do this problem. Thank you for watching.